My name's Hazem Gaber, and today we're gonna start writing code. And as I said before, we're not going to learn any specific language, but we're gonna start by learning variables. So, what's a variable? Well, in any program, we always have data. So every program has really three parts if you think about it. You got your input, and then so you got to take some data in, and then you got logic. So you're gonna process the data, and then you got output. So you gotta release the data. You gotta give the user something useful. And so we have to store this input somewhere, and then so that we can apply logic to it. And then once we're done, we gotta store our output somewhere. So that gives us a variable. So a variable is a word. It's a it's a container, if you will, that stores data. And we might, depending on the language that we're using, we might need to declare the variable. So when we declare a variable, we're telling the code that we're creating this container, and we give it a name, and we might tell the the software what kind of data we're storing in that container. And this really only applies to C, but with C, we might also tell it where in the memory we want to store the data. So if I have a big chunk of RAM, I might with little portions, we want to say, like, let's say our variable is going right here in position 4 or whatever. We can give it an address, and then later when we want to take our variable back, instead of saying give us, the temperature variable, we say give us the data in the memory position 4. Now, the higher level languages don't do this because what ends up happening is, um, in the past, one of the problems with C was when you closed the program, the variable stayed here. So this piece of memory uh, stayed full in the computer, even though the program was not running anymore. And eventually, all your memory filled up until your computer crashed or you restarted it. So, newer, higher level languages have something called garbage collection. So, that means when you close the program or when you're done with the variable, we just clear the content. And that's really important for building efficient, user friendly programs. So there's a whole bunch of different types of variables. And the reason that we do this is so that we know, um, we're telling the program this is what we're storing and this is how big it is, so that you know what to expect. So a character, for example, is a single letter or number. Uh, a string is a sentence, basically. So more than one character. And then an integer is a number with no decimal. So, but different programs have limits. So you can't store, you know, a number that's like a trillion. I mean, you can't store, you know, say a number that's like massive, you can only store a certain limit of numbers. And then we have a bool, which is actually true or false. That's all you can do, which is actually like 0 or 1. And then we have a single, um, and single is a number, but it's got more detail. So we can store um, it depends on the language or the processor. So if we look at basic, for example, so a single is actually 4 bytes of data, but we can store any number from negative 3.4028255 235 times 10 to the 38 all the way to negative 1.401298 times 10 to the negative 45. And we can store 3 or 1.401298 times 10 to the 45 all the way to 3.402835 times 10 to the 38. Now, if we make a number line, and here is 0, and here is infinity, and here is negative infinity, so this is a very big number. So 3.4, it's basically 3 with like 38 zeros behind it. You know, it's a huge number. And if we take this number, it's a negative 3 with like 38 zeros behind it. So it's a humongous negative number. And then if we take this number, it's not 1 point, it should say negative 45. So this number is not 0, but it's 0 point and then 45 zeros and then a 1. So it's just close to 0. And then this number is the opposite. It's a negative, very close to 0. So what we end up with is we can store all these numbers. We can store all these numbers. We can't store anything that's more, because that would take too much data to represent. And we also can't store anything here. So numbers that are really tiny, close to 0, either positive or negative, we can't store them because there's too many digits. So why this exact number? That's a very complicated answer, and it has to do with the way that computers add, and so computers add up 8 bits make a byte, and so when a computer wants to add 3, 4, 5, 6, so there's 1, 2, 4, 8, 16, 32. So computers use a a kind of a table to add. If you look at these numbers 1, 2, 4, 8, 16, 32, 64, and 128, I can I can take any combination of these numbers and I can add up any number from 0 to 255. And so if I wanted to, this is how the byte is. And so these are bits. So this can be a 0 or a 1. So for example, if I wanted the number 8, I would just turn on number 8. So we just give this a 1. And we make the rest of these zeros. So we can represent the number 8 as 0, 0, 0, 1, 0, 0, 0, 0. Or if I wanted the number, I don't know, 28, I could turn on 4 and 8 and 16. So 16 plus 8 plus 4 makes 28. And I turn all these as zeros. So 28 can be written as 0, 0, 1, 1, 1, 0, 0, 0. So that's why this ends up the way it does, just based on how computers store data. A double has 8 bytes, so we got more precision. And then a blob is exactly what it sounds, so it's just a huge amount of data, and it can be any type of data that you want. So this is why we have to be careful. What happens if we don't declare the variable and then stick the data in it? So if I'm writing some code and I have, say, an input box, and I say and say my variable is name, username. So I might write some code, say declare variable username as string. So I'm just writing pseudocode here that doesn't necessarily apply to any language, but basically I've told the computer that I want to make a variable called username, and it's going to be a string, and then I will just do input username. So now we're asking the user to input some data, and we're going to store it in the username variable. Now, if I was missing this sentence here, and then I asked the user to input his username, depend on the language, this might be totally valid or it might fail. So if this was a C++ program, it would fail. We'd have a fatal error and the program would crash. This was PHP, nothing would happen because with PHP, the first time you use the variable is the automatically creating the variable. So can we add two variables of different types? And here's another weird thing. So if I have a string, let's say string 1, and I store the number 5 in it, and then I have integer 1, and I store the number 8 in it. Now, can I do a math operation? And I go string 1 plus integer 1 equals. So this could really mess up your program. This will fail because um, you can't add a string and an integer because the computer isn't thinking of this the way a human thinks of it. It's representing the number 5 as a character, which is in itself a number. So, or a bunch of bytes, and then it's trying to add that to the 8. It won't work. But it depends on the language. So if you create a string but didn't tell the computer it was a string, you just stuck some data in it, and you can have all kinds of weird results. And the result depends on how the programming language you're using stores data. And then here's another question. If we have integer 1 is equal to 5, and we have single 1 is equal to 3.25. Can we add integer 1 plus single 1? And usually the answer is yes. The question is, is our answer 8 or is it 8.25? And that depends on the language, and it also depends on the type of variable we're using to store our result. So if we're storing our result as an integer, we're going to get 8. And if we're storing our result as a single, we're going to get 8.25. Any questions? Please leave a